just in case somebody wants to look at it later. Um, with the balancing page that I went through yesterday, I went and finished it. The two doozies on that one are 22 and 25, I think, unless I totally messed something else up. Some of them, those hydrocarbon ones, I pulled those one out specifically. When I did this one, I looked at it and said, oh gosh, the problem is sodium in two spots on one side. I've got water here, and the only source of oxygen is there, so I'm going to break up H and OH. So I said, there's three chlorines, so I'm going to put a 3 here. So that gave me 3 chlorines with 3 sodium and 1. 3 and 1 made 4, so I put 4 sodiums there. All right, so 4 sodiums gave me 4 O's and 4 H's. If I look here, I've got 2 oxygen, so I've got those kind of already taken care of, so I need 2 more. Well, if I double this, that gives me 2 here, plus 2 there is 4, and then 2 2's. Oh, I went and did it the first time I did it, and I can't remember where I started, and I had stuff all over the place, and I had crazy numbers. That one was easier than I'd expected. The other one that's tricky is this big, crazy long one. The thing to start with this one is sulfate because it's in 2 places. So if I have 3 and 3 make 6 of them, I started with throwing a 6 there. Technically, those are both 1s. So that gives me 6 sulfate. I know I'm going to have to break up that chromate because it's not the same thing. So 6 sulfate gave me 6 iron. Well, because sulfate's in 2 different spots, the last thing I want to do is add things here. So 2 iron and 4 iron gives me the 6 that I need. That gives me 12 chloride plus some other stuff. So I did iron, and then I looked at chromium. Well, I've got 2 chromium there. If I don't do anything with that and put a 2 here, chromium is balanced, iron is balanced, sulfate is balanced. Those are my first 3. Sulfate, iron, chromium. Then I would look at lead, 2 of those, 2 of those. So once I got all of those balanced, I said, okay, I'm going to look at chlorine. 3 4s are 12, plus 4 is 16. So it's easy to balance chlorine by just throwing a 16 in there, so that's good. So then all that's left would be H and the O's from there. And the only place we have H and O is here. 16 hydrogens, balance the hydrogens with an 8, and then I've got 8 oxygens. It was actually easier than I thought, I think. No, it wasn't this one. There's one that I gave one year that I had to balance. Like, I went a little bit crazy and then did something else, a different method. So after we talked about balancing, we talked about there's 5 types of reactions that you're supposed to know. There's combination, which is putting 2 elements together, calcium and oxygen, calcium and chlorine, iron and chlorine. That one happens, or well, one similar to that happens if you have a rusty car like me. And that one also happens spontaneously, but there's differences. Technically, you can combine 2 elements or 2 compounds, but it gets a little bit tricky. Then we had decomposition reactions, which is one thing falling apart into multiple things. They normally need a little bit of a kick, but they will go eventually. Oh, we got somebody else. Ryan came. Then single replacement is where you're taking an element and kicking an element out of a compound. So the first example here is sodium and potassium chloride. Sodium is a metal, potassium is a metal. They're going to switch places. And we get potassium and sodium chloride. We have to think about formulas when we're doing these. Aluminum kicks out copper. Zinc kicks out hydrogen. We can react things with water to kick out one of the hydrogens and make a hydroxide. There's that activity series, which I'm not a super huge fan of, but it tells you what reacts with what. Uh, and then we can look at them non-metals. Normally, you're just going to see these with halogens. The high, you're going to replace one with something that's higher. So fluorine will replace chlorine. Bromine will not replace chlorine. Iodine will not replace chlorine. Iodine won't kick anything out. And one of the things after we finish today, it's identifying reaction types, and it's a little bit more balancing practice. And then we'll look quickly at combustion. So single replacement is like cutting in at a dance, kicking somebody out, switching. There was an old TV show, I think it was probably on Fox, called Wife Swap, where you took two wives from different types of families and they switched, and you put some rich uppity person in a more blue collar thing, and that was a different situation. So double replacement, we're going to have two things trading places. These are generally going to be ionic compounds or acids, and these are usually done in an aqueous solution, so this is stuff that's done in water. So it's about charges. So I've got sodium hydroxide and iron 3 chloride. So I know, well, not with a highlighter. Sodium ions are +1. Hydroxide ions are -1. Chloride ions are -1. 3 of them makes that an iron 3. So what happens, like if I throw this all in a bucket of water, we get sodium ions, we get hydroxide ions, we get iron 3 plus ions, and we get chloride ions. So you throw that all in a pail of water and this happens. Well, this positive ion and that one can pair up, and so it's just we're switching. I usually liken it to the metals switch places, but you can liken it as either. So you have to build a compound of sodium and chlorine. Well, +1 -1, so that's NaCl. Iron 3 and hydroxide, well, they can make one, but we need 3 of those. And then we can balance it. I need a 3 here, a 3 there, and I think that's it. So metals trade places. Typically, this doesn't happen unless one of the products doesn't dissolve in water. So if you mix those two together, you're going to get a reddish, I think iron hydroxide is reddish. That's going to become a solid. It's going to fall out. This is where I can't really, I can show you a video, but you can get bubbles, or you generally, one of your products is water, and that's usually in an acid-base thing. So I've got some examples down here. That's supposed to be an arrow, and then that's a little bit of a summary. So if I'm looking at one of these, calcium we know is +2, chloride is -1, +1, -1. Well, I'm going to take the positive from the second one and join it with the negative over here. So +1 -1, that's going to make NaCl. The +2 here and the -1 there, well, I know I need calcium, I need 2 OHs. 2 chlorine means I need those 2 ones get a 2. And that's that. That's the easiest way to kind of think about it and do it logically. Chloride is -1. Copper in this case is +2. Sulfide is -2. Potassium is +1. A positive from one, negative from the other. Potassium chloride. Negative from the second, positive from the first, plus 2 minus 2, and that needs a 2. Uh, that's a solid. That's a solid. There's a solubility table on your periodic table that helps you know these things. Plus 1, minus 1, plus 1, minus, no, plus 3, minus 1. So negative and positive, that's that same iron 3 hydroxide. Potassium goes with nitrate. 3 nitrates. I need 3 of those. 3 hydroxides. 3 of those. These ones are, unless we have like a plus 2 minus 3 or plus 3 minus 2. These ones, as long as we get a plus 1, they're usually, speak of the devil, fairly straightforward to balance. Hydrogens and acid are plus 1. Phosphate is minus 3. Calcium is plus 2. Hydroxide is minus 1. So positive and negative, Ca plus 2, PO4, 3 minus. Means I need 3 plus 2s. Now, this I did yesterday in 2 colors. Those hydrogens are, the red ones are from the acid. The green ones are from the base. So plus 1, minus 1, I treat water as kind of like an ionic compound. Well, so we have that 3 calciums. I need a 3 there. 2 phosphates. I need a 2 there. 2 3s make 6 red hydrogens. 3 2s make 6 green hydroxides. So double replacement, even if you're making water, identify your charges when I ask you to predict products, and then pair positive from one, negative from the other, positive from one, negative from the other. We normally look for reaction types. Element E is an element, C is a compound. 2 elements, combination. 1 thing and an arrow, decomposition. An element and a compound, a single replacement, and 2 compounds. And this one is generally going to be ionic or acids, like so. I don't know why that popped up. So those are the first 4. These 2 pages here are, you don't have to worry about predicting products. We'll talk about that again on Monday, even though we've done little bits of it, and there's some practice with that I'll get rid of. The last type is combustion, which is burning things, which happens in your gas tank. That's it's called an internal combustion engine for a reason. Your propane barbecue, if you have natural gas for heat or heat with oil, you're taking something with generally carbon and hydrogen. You can have other things. You can have nitrogens, you can have sulfurs and all of that. And then every once in a while, oxygen, some sort of organic compound reacted with oxygen. And there's technically 2 types of products. We can have what is called complete combustion, which is where everything goes as well as it can. That's the better, quote unquote, of the 2 because it produces carbon dioxide and water. Carbon dioxide isn't spectacular, the whole greenhouse gas and all of that. However, if you have complete combustion, you're making 2 things that are relatively benign. They're not going to kill you. Incomplete combustion is when there's not enough oxygen to go around. You start producing carbon monoxide. And well, that's bad because carbon monoxide will preferentially bind to the hemoglobin in your blood, and then you don't get enough oxygen. And then when you don't get enough oxygen, well, you can start to suffocate and die, and it's generally pretty bad. Sometimes you can, if there's really not enough oxygen or so much carbon that it's not funny, you can just get carbon. That's going to be like your ash. So you're always going to be reacting something that's going to be C and H usually with oxygen. So complete combustion, if we have C4H10, which is butane, which is in a cigarette lighter or a barbecue lighter for that matter. I'm going to redo that because it just looks bad. C4H10. If it's combustion, oxygen. This says complete, so the products will be CO2 and water. Incomplete combustion is going to start looking the same. But if it's incomplete, we're generally going to say CO and H2O. We have to be able to balance both of them, but it's like one of these oxygen's the end. 4 carbon, 4 carbon. Okay, we're good. 10 hydrogen, 10 hydrogen. So those are balanced. Let's do oxygen. 4 and 2 make 8, plus 5 is 13. Well, I can't put a whole number, natural number technically, in front of oxygen to make 13 because 2 and 13 don't work. So we double this. Well, 2 4s, that's going to be an 8 automatically. That's going to be a 10. 2 8s are 16 plus 10. Well, that's easy. 26. Now I can throw that in front and 2, 13, 8, 10. If you have one of these where you have an like half of 10 is 5, when you divide that number by 2 and get an odd number, a lot of times you're going to have to double something. So sometimes I just straight up double them. Incomplete combustion starts the same way. 4, 4, 10, 5. This one's going to be, well, again, the same issue. 4 oxygens here is 9. Well, I can't do that, so I'm going to put a 2 there. That becomes 8. That becomes 10. 8 and 10 make 18, half of which is 9. So lots of oxygen, complete combustion. Less oxygen, incomplete. These can get somewhat tricky. Your body does this. C6. I don't know how it does it. I know how it does it. We breathe in oxygen. Your body says, okay, I'm going to convert that through, we don't burn it as in like a literal fire. There's all sorts of enzymes and things that help do this. Carbon dioxide and water. Start with the carbon. 6 carbon, 6 carbon. 12 hydrogens, 12 hydrogens. 2 6s are 12 plus 6 is 18. So I know I have 18 oxygen as the products. I've got 6 here, I've got 2 there. We don't want to change that number because changing that number means putting a coefficient here. Well, now I've got 12 carbon, so I got to go back. I've got 24, I've got to go back. So if you're doing something with oxygen in it, the trick is I've got 6 locked away. So how many more are left? 12. Well, half of 12 is 6. 2 6s are 12, plus 6 is 18, and now those are balanced. Sorry. Somebody's crying upstairs. I hope Ben didn't do anything stupid. Oh dear. Thankfully Brittany's okay, but we'll finish C2 860 02 CO 2 3. Well, 2 plus 3 is 5 oxygen. Well, it's, uh-oh, 5 and 2. We have a problem. I've got 1 here. Well, that one's already locked away. So I've got 4 left. Well, I can put a 2 there. And 1, 2, 2, 3, and that one's all done. So your kind of practice for Monday are these 2 pages. Identify element, formation, element. Oh, one thing and that. If you have one thing, it's decomposition and identifying reaction types of the 4. Compound, double replacement. Compound, element, single replacement. So that's all I've got for you today. I'll save this video and post it for those people who are there. I think technically, I can't remember which class had an assignment on which day. This tells us, I mean, the quicker you have it in, the better, but, oh, today, 9. 2 people did the calculations one, because eventually we've got to do a balancing one. That's all I've got to say until Monday. Oh, we've dropped a couple. If you don't have any questions, go enjoy the sun before it starts to rain and potentially apparently snow this weekend, which is ridiculous. Locusts are coming next, I swear. But have a good weekend. Be nice to your mothers. We will.
Thank you.
You're welcome.